Good afternoon, everyone. We want to welcome all of you to this second session of the training program for the South African Maths Olympiad Round 2 Junior. We met last week, and during that session, we completed the 25 problems which appeared in the 2018 paper. Today, we would go on to the 2019 paper, which has also got 25 problems. And these problems were posted about two or 3 days ago. I trust, more than hope, that you have tried those problems so that when we confront them today, you would be familiar with them, because we don't spend too much of time on the problems, the statements, we go straight to the solutions. So, all right, with those few words, I just want to reiterate that you must have your speakers off. You must have your speakers off. The speaker is that little symbol which has got mute written on it on the bottom left-hand side of your screen. Make sure that that mute button is crossed. Otherwise, we would be able to hear what is happening at your front. And we've got 140 people at the moment, expecting 200 people, and you don't want them all to hear what's happening in your room. It's more than that, it's a great disturbance for me, and I have to stop and talk to you and ask you to do that. Okay. So now why is somebody sharing the screen? Brindry Flanagan, please don't do what you're doing. Please don't share your screen with me. All right, so let's go. We are going to start as you can see on the screen. We are doing selected problems from the 2019 paper. By that I mean I'm not going to do the very easy problems which occur right in the beginning. This is round 2, and I am quite certain that all of you will know how to do those extremely simple problems. So we go straight to problem 5 so that we have more time to spend on the rest of the problems. Okay. All right, so let's go. The very first problem is this one. It's got 2 square roots. As you can see, the way to do this is to work out the inside square root. Now you got 20 plus 16, and that is 36, and the square root of 36 is 6. So this part is 6. And now you go to the second square root. 19 plus 6 is 25, and the square root of 25 is 5. And then now you go to the last one, which is square root of 20 plus 5, which is 25. Square root of 25, and the answer is 5. Right. One important thing is that be careful. Sometimes you might be tempted to say the square root of a squared plus b squared is a plus b. Very often people do this. And this is completely false. As you can see, the square root of 3 squared plus 4 squared is 9 plus 16, and the square root of that is 5. That's not equal to 3 plus 4. It's not 3 plus 4. It's some other number. Okay, so just be careful with that. Okay, let's get on to the next problem. Okay, the next problem is a problem regarding areas. And you're asked to find the area of this shaded region. What percentage of the diagram is shaded, right? Now one can guess, but that can, you can never be certain with guessing. Now, how do you find out what the percentage is? The trick is you've got small squares and you also have large squares. You can see you've got these small squares here, these small triangles at least. The small triangles, and you got some large triangles. But you'll observe that the large triangle is really twice the small triangles, right? I put two together. Okay, so you can add all the triangles if you like and see how many such shaded triangles you have by counting just the shaded parts, right? And then you'll have to know how many triangles there would be altogether. And an easy way of doing this is to draw these dotted lines as you see here, right? And that separates these triangles very nicely. But what's interesting is that in each of these squares, the shaded part takes half of it. Look, each one. The shaded part is half the small square, right? So by drawing these lines, you can see that each square is half the little square that it sits on. So it stands to reason that the entire shaded region is 50%. Question was, what percentage? Always answer the question, what percentage of the diagram is shaded, right? You could have counted all the shaded parts as small triangles, but then you will have to know how many triangles there are altogether. And that's not so easy because you got some white parts here and another part here like this. But when you do it like this, then you can actually see it. In fact, here in this diagram, you can count the white parts and you can count the shaded parts because they are broken up, they are partitioned quite nicely. Okay, so the next problem is how many paths are there from A to B, from A to B, there's A here, there's B here, and the paths from A to B, if you can move downwards and to the right. In other words, you're allowed to move downwards and to the right, like that. So there are many paths. You can come down here, downwards, to the right, downwards. You're not allowed to go up, right? Okay, you're only allowed to go downwards and to the right. Now, there are many problems like this. In fact, this one here is a small diagram, a 2x3, but it can be quite complicated if you have a bigger diagram. If you've got 3x4 or 4x5, and there's a very large number of parts, and when you try to do it, like for instance, even this is a path, see? Or this is a path. You try to do that and say, okay, have I done everything, A and B? Are there some things, have I counted anything twice? You'll find it very difficult to do that. So you need to have a strategy to decide how to actually do the counting. Now, the observation here is the following, that when you go to any intersection point, let's just go to my screen here. When you go to any intersection point, I'll explain these numbers in a moment. Suppose you got an intersection point here, right? You're coming from there to this point here, right? Now, how many paths are there from here to here? Well, the answer is, now listen carefully, it is the number of ways of getting to that point, right? Once you get to this point, then you can get to this. And the number of ways of getting to this point. But once you get to this, you can get to this as well. Those are the only 2 points which contribute to this circle point, right? So if you want to find out how many paths there are, you have to know how many ways can you get from here to this point, how many ways can you get to this point, and how many ways can you get to this point, and you add those 2 ways. Now, that's what I've said here. If A is the number here and B is a number, then the number of ways to get to this point is A plus B. Now, what do I mean by this number? At this point, we write down how many ways can you get to that particular point. So we need to see how many ways can you get to any particular point. So let's start from A. Now, there's only one way in which you can get from A to this point. That's the only way. Likewise, there's only one way to get from A to this point. So I put a 1 here. And here too, there's only one way to get to this point. And vertically downwards also, there's only one way to get to this point. There's only one way to get to this point. So we put 1s here to indicate that these are the number of ways you can get to those points on the flanks. So here, the number of ways to get to this point is, now we can say we use this principle. It's 1 plus 1. So you get 2. So I put in a 2 here. Now, once I put a 2 here, then 1 plus 2 gives me 3. 1 plus 3 gives me 4. So there are 4 ways of getting from A to this point. You see? So there are 3 ways of getting there and 1 way there. So 4 ways. So it's a simple addition rule that you do. And like that, now once I've got those 2 numbers filled in, you can fill in this comes 6, 3 plus 3 is 6. And eventually you see that the number of ways of getting to B is 10. See? So this is a strategy, and it allows you to do even more complicated problems. And if you got 4 by 5 or whatever, of course the numbers will become bigger and bigger, but it's a simple way of deciding getting to the solution of this problem. It's a good strategy. So I hope you don't forget that. Sometimes they have a little a blockage at some place here. You may have, they say, you're not allowed to go through this point here, like that. See? But again, you can argue the case, right? You're not allowed to go through this point, but you can still use the same principle to get to your answer. Okay? So there are variations of that problem. All right, so let's get on to the next problem. Okay. So this problem says that a regular decagon or decagon, deca means 10, decimal is coming from the stem, DEC, decimal, counting tens, right? Or December. Oh, December, it should be the 10th month. Okay, but it's actually the 12th. Okay, there's a history behind that. Maybe it'll be interesting to find out why they call it the 10th month when it's actually the 12th. You can go and research that. And probably you can get some other words which look like that. But here, this is a decagon. It's got 10 sides. And if you count the sides, you see there are 10. Now the question is, what is the value of x? What is the value of this angle? Now, this is not any decagon, it's a regular decagon. A regular decagon means, let me Let me go to the next slide. I just want to make a couple of remarks about regular pictures. So what do you mean by regular? You have regular polygons. Need not be a 10-sided figure, but in general, polygon could be 4-sided, 5-sided, or any number of sides. Regular polygon is one which has got equal sides. All the sides are equal, and all angles are equal angles. So if a polygon has got 10 sides, it's got 10 angles. So generally a polygon with n sides has got n equal angles. Now, what's interesting about regular polygons is that regular polygons always have centers. This need not be true for polygons which are not regular. Like if you take, for instance, a quadrilateral it's not clear that this thing has got a center, right? But by center, I mean that there is a circle that can actually be drawn through all the vertices. Now here, the circle need not be able to drawn through all the 4 vertices. So when sometimes you have polygons which have such properties, but regular polygon, you always have centers. There's always a circle that can draw, that can connect all the vertices of a regular polygon. So once we do that, so this part here is actually the center, as you can see, although it's not obvious, but I'm going to just assume this is the center. And in fact, all the see, I can connect opposite vertices, and you'll see that all of them go to the center. So these 10 sides, that they create 10 triangles. And as I said, this is the center of a circle. So it means that all these are actually all equal, they're all radii. And the sides we said are equal. So you can put a double stroke like that. So it means that all these triangles are congruent. You can see they're all 3 sides, you see? So they're all congruent, which means that all the angles are also equal. So all these angles are equal. These 10 angles are all equal. Yeah. So we can see 10 angles at the center are all equal because of congruence. Right? I presume you know about congruent triangles now. But congruent means they're identical. These triangles are all identical, because if you cut each of these triangles, you can place it exactly on the other one. So they're identical, and therefore the angles will be the same. But there are 10 angles here in the center. So what we've got here is the x is, so we can say each. What is each angle equal to? Well, the 10 angles add up to 360, and all of them are equal. So each one will be 36 degrees. And the x here, which we had originally, you can see it covers 3 angles. So x is equal to 3 36s. You calculate that, you get 108 degrees. So the important thing about this problem is that every regular polygon always have a center. And then you can have a radius, and all these will be equal. All right, so that is the solution to this problem. Let's get on to the next one. So we're now at problem 11. The pattern below contains consecutive odd numbers. 1, okay, the first row has got only 1. The question is, what is the value of n if the sum of the numbers in row n is 1000? All right, you got row 1, row 2, row 3, and somewhere along the line you got row n. We don't know what n is, right? But we do know that the sum of the numbers in that row, when you add up all these numbers here, you're going to get 1000. Tando Mabena, please put off your, okay, thank you. Okay, so when you add up all these, you get 1000. Now, what is n, right? So obviously what we have to do is to see what happens when you add these numbers. Maybe there's a pattern. Okay, let's add the numbers in each row, and you will see the first row, you just have a 1 here. I'm going to put 1 far away. Second row, you got 3 plus 5, which is 8. The third row, you got 7, 9, 16. These are all numbers, 1, 3, 5, 7, 9, 11. So 7, 9, 11, when you add them, you get 16 plus 11, which is 27. And then when you do the next one, after 11, you get 13, 15, 17, 19. If you work this out, you get 64. Right? And this gives you 125. Now you ask yourself, what is the pattern here? Well, you can see clearly that when you factorize these are cubes. This is 1 cubed. This is 2 cubed. 3 cubed. Interesting. Very interesting that these numbers add up to cubes. And of course, this is 10 cubed. So the numbers in the 5th row is 5 cubed, the 4th row is 4 cubed, 3rd row is 3 cubed, and therefore this is 10 cubed, so n is equal to 10. So the numbers in the nth row or the 10th row should be the cube of 10, which is 1000. Okay, all right, so let me just stop here. And I want to just look at many statements in the chat column. I just want to see what people are saying. Now, there are people who write a lot of things in the chat column as though they are having a conversation. I would ask you to refrain from please doing that. Riya Lachminarayan is making some statement. Another one says, what kind of rule is that? You don't ask the people around you any questions. At the end of the session at 6 o'clock, we will close up and I will give you a chance to ask your question directly to me and I will give you an answer. And please don't use this chat column for all kinds of frivolous conversation, right? This chat column is meant to ask any questions which you don't understand. Then when I get to it at 6 o'clock, I will see what the issues are and I will discuss them. Okay, so there are people who are speaking about higher level maths. Of course, if you are in round 2, then you're not speaking about grade 3 mathematics here, right? And in Olympiads, you need not do the kind of mathematics that you do in school. You have to use your intelligence and you have to use the information that is provided to answer the problems. All right, you will see, as we go along, we have many, many examples like that. And so don't rely on your previous knowledge. What you have to do, let me just explain this. Mathematics is about problem solving, not what you remembered in the classroom and what your teacher taught you, right? The teacher will teach you certain things and you have to remember that, obviously. But in mathematics, you have pieces of information which are given and you use that information and the mathematical knowledge you have got already to try to answer the question, right? So there is no need to be concerned this is a higher grade or standard grade or whatever. There's no grades here. It's all about understanding the question and answering it, right? From first principles. And this is what I am doing here, okay? So maybe earlier on I spoke about polygons and people are asking, why are you speaking about polygons, right? Because the question speaks about a regular decagon. So I need to speak about that so you can understand the question, right? Okay, so let's just get on to the next question. The next one is going to problem 12 now. Let's read the question. 18 identical rectangles are arranged as shown below. Now, in a question, you have to digest all the pieces of information. So these rectangles are identical. Right? They got exactly the same sides. Okay. Sponga, please mute your screen. Sponga. Determine the area of the rectangle ABCD. So you need, there's your rectangle ABCD. You need to find the area of the full rectangle. But what they give you is the length of the bold path. So there is a pathway here. They tell you what the length of this full path is. And that is 36. Okay. All right. So you know the length of the full path. And the problem is to find the area of the rectangle. Okay, so let's have a look at this. So what we have here is we don't know what each piece is. So if you look carefully, you will see that the first part is the breadth of the rectangle. We don't know what that is. So let x be equal to the breadth of the rectangle, of the small rectangle. So this part here is x, right? So, and this part here, well, this part is exactly the same as that part. So that must also be x. Now here you got two of them, right? So let's just, we need to see that the sum of the whole lot is 36. So let's track this part. You got x here. Here you got 2x. Here you've got 4x, 4 of them. Here you've got Well, we have to think about this. Well, it's equal to the whole thing minus 2x. So the whole thing is 4x. So that is 2x. That's also half. This part here. This part is also 2x. This is 4x. The length is 4x now. We've just seen that. There's the length. It's 4x. So we here, and then we have another piece here, another piece here. So when you add all these pieces, you get 36. And now you got an equation involving x, and you can actually calculate x. When I add them up, I get 4, 8, 10, 18. The 18x is 36, so x is 2. All right. Okay, so now we need to find the area of the rectangle, and we know that x is 2. So this is the length, which is 4x, which we saw earlier on. And this part is also 4x. And the breadth is this x here. Oh, I'd rather do it at the bottom here. You got 4x here and 4x here. So this way is 8x. What do you need? You need to find the area. Okay, so what is the area of a rectangle? So we need to work out the area of a rectangle. That's length times breadth, as you know. And this way you've got 4x plus 4x, which is 8x, multiplied by, and this way you got 4x plus another x here, which is 9x. I could substitute the x equals 2 straight away here. Or I can multiply 8 times 9 is 72 x squared, and x is 2, and 2 squared is 4. So this is 72 times 4. And 72 times 4 is 288. So that's the answer to this problem. Right, to summarize, there is an unknown length here. You know this full length is 36. So there is an unknown length. We don't know what the length is and what the breadth is. That's not given. So give a name to the breadth. I chose that because I can use 4 breadths in this, where I am here, to give you the lengths. So that is how the length is 4x. And that way you can calculate the full length of the line, and you know that is 36, and you have an equation involving x, and that equation can be used to solve for x. And then once you get x, you can work out the area of the rectangle, because you know the formula of the area of a rectangle is length times breadth, and you can solve it. Problem 13. The shape alongside is composed of horizontal and vertical lines. Okay, as you can see. 3 distances are shown in centimeters. So you can see this distance here from here is 11, this is 9, and that is 2. Determine the perimeter of the shape in centimeters. Now, what do you mean by perimeter? Perimeter means the sum of all the sides. So it's that side plus that side plus that side plus that side plus that. Now, this is really weird because a lot of sides are not given. You're only given 3 parts of the perimeter. There are other parts like this one, and this one, and this one. We don't know what these things are. Right? So how are we going to find the perimeter? Because the perimeter means you're adding all the lengths all around. Right? So this requires a little bit of ingenuity. So how can you find the perimeter just given these 3 numbers? All right. So let's go straight to the solution to the problem. Okay, now what I have done here is the following. There's a very nice way of solving this problem. What I've done is I tried You see, I know the perimeter of the full rectangle, but the rectangle is not drawn. So what I'm going to do is take this piece here and push it to the edge here. That is the blue. So that part has been removed. Right? This piece here has been removed and we translate it to that. We have to add that piece. This is one of the pieces that we have to add. All right. Then the other thing that I do is I go up like that and I divide this part here into two pieces by completing the rectangle. Right? This part is 2, and there it is. But this part here, I bring it down. You can see this part is being brought down. That's the green. Right? Okay, so now that part is missing, that part is missing. But the next thing I do is to take this piece here, a small piece, and push it to the end. So that's the red piece. This part here is now the red piece. So your perimeter is equal to all these numbers which you see here, together with the blue, the red, and the green, because those are the same pieces of the boundary which have been transferred. The reason why we did all this is that now you can see I push them to the edges and we know how to find the perimeter of the original rectangle. This is 11, this is 9. So the perimeter of this entire rectangle is 9 plus 11, 2 into length plus breadth. Or if you want, you can just add up all these things, 2 9s and 2 11s. This is 9 here, this is 11. Right, so this includes the blue and the red, green and the red. And you got 2 other pieces which we already know to be 4. 2 plus 2. Now, there it is. That gives you the required perimeter. You push some unknown pieces to the end, so you know the area of, the perimeter of the rectangle. So 9 plus 11 is 20, 20 plus 20 is 40, 44. That's in centimeters, because everything was given in centimeters. And you see, this is a good problem-solving exercise. If you don't know how to do it, you have to think now. You have to think, how am I going to find the perimeter of this object when so many pieces of information are not given? You only got 3 pieces of information. So this is what we call problem solving, where you can actually cut this perimeter up into pieces and reposition them, so that, as I have done, so that you can find the perimeter of the new repositioned diagram. And what happens is that you reposition them so that you can get to the perimeter of a rectangle. You know how to calculate that. Okay, the next problem says for any positive whole numbers A and B, the operation A, well, I don't know how you call this, A, we'll call it cross. A cross B is defined as, and you got this thing here. And let's understand what you mean by this. These numbers A and B are positive whole numbers. They're positive, they're whole numbers. In other words, like 5 and 6 or something like that.
Oh, who is this?
They're positive whole numbers.
Oh my gosh.
Okay, Watermelon, please put your Watermelon. I'm going to take you out of the class if you don't listen.
guy. Kinakatam. Fakaka. Control.
I'm going to remove Boitumelo from the class.
Prof, I think you have to remove Mutumelo from the class.
Yes, please. Yeah.
Thanks, Prof.
Have you done it? Is that Patrick? Yeah, please do that. Thank
Thanks.
you.
She's removed.
Okay, thank you.
Yes, it's Patrick.
Yeah, thanks very much, Patrick.
Mutumelo, she's back again. She's back again.
Then she needs to be... Okay, let's go on. Thanks very much, Patrick. Please try to handle that. Okay, so determine the value of x if x cross 19 is 70. Let's try to understand what this is. This is an operation. This is an operation like plus a plus b or a minus b or a times b. And this is a new operation. And the operation says that you square the first number and square the first number, a squared, that's your first number. And you add the second number, you divide the answer by 2, right? So let's take an example. For instance, 7 cross, say 5 is you square the first number plus add the second number and divide the answer by 2, and you get 49 plus 5 is 54, and the answer is 27. So you can calculate what 7 cross 5 is. Like that, you can calculate any cross.
Prof, I think Mutumelo keeps coming back.
I'm trying to mute her myself. Yeah. Okay, sorry about that, the rest of the class, but we have a problem with a student who doesn't follow instructions. So we have to remove her. All right, so in this problem here, you got determine the value of x if x cross 19 is 70. So let's just do that. I've actually done it for you because it just becomes a calculation now. So x cross 19 is x squared plus 19 divided by 2. That's the rule. And this is equal to 70. So the moment you got is equal to 70, you have an equation. You have an equation involving x. There it is. So we can solve for x. How do you solve? You multiply by 2 on both sides to get rid of the fractions. You get x plus 19 is 140. And then you bring all the x to one side. And you got x squared is equal to 140 minus 19, which becomes 121. The square of x is 121. So x is 11. And it's 11 or minus 11. If x squared is equal to 121, it could be x could be negative 11 as well, because negative 11 times negative 11 is also 121. But they say that x is positive, so negative 11 can be discarded. It's not accepted. Okay, so that is how you solve that problem. The next problem. Problem number 15 says, the diagram shows two parallel lines with 6 points indicated. Well, you can see 4 points at the top and 2 points at the bottom, which makes 6 altogether. How many triangles can be drawn with their vertices chosen from these 6 points? Right? A triangle has got vertices. It's got 3 vertices. Right? And you want to choose those 3 vertices from these 6 points. So I must choose 3 vertices from these 6 points. Now, obviously, you cannot choose 3 vertices on the same straight line. That would not give you a triangle. So you have to choose vertices, maybe 1 vertex from there or 2 vertices from here, right? But not 3. So you can choose 1 vertex from here or 2 vertices from here. All right. Now, if you choose only 1 vertex from here, it means you are choosing both these at the bottom. I'll repeat that. If you are choosing only 1 vertex from the top, you're choosing both of them here. And that will give you, if both those are chosen, then what happens is that you've got how many triangles? You've got 1 triangle here, another triangle here, another triangle here. Because the 3rd point can be chosen as any one of those 4 vertices. Right? The 3rd point can be chosen from any one of these 4 vertices, and that will give you 4 triangles. That is provided that I chose both the vertices at the bottom, right? But it's quite possible that I choose only 1 vertex from the bottom, in which case I have to choose 2 vertices from the top. So just remember this is 4 vertices here. And I'm going to now look at that situation where I choose 1 vertex from here and 2 vertices from the top. All right, so we already have 4 triangles. If just one vertex is, sorry, if both were chosen, I've got 4 triangles. Now I'm choosing only 1. Okay, so let's have a look at this and see what's going on here. Now here, suppose I have chosen this vertex. Now I can draw lots of triangles like this, lots of lines. How many triangles are there in this picture here? Well, you can see the 3 small triangles, 1, 2, 3, right? The smallest triangle. Then you got these triangles here, right? Where you got these vertices separated by 2 units. There and there, there's only 2 of them. 2 of them this size here. And then there's only 1 having this large size. So in this figure here, there are actually 6 triangles. There are 6 triangles in this picture here. Now that is if I chose this as your vertex. But on the other hand, I could have chosen this as a vertex, in which case I would have had this kind of situation. And even for those, I have another 6 triangles. So if I chose this as my 3rd vertex, I would have another 6. So altogether, we've got 6 plus 6. So there are 12 in this case. This is where you have only one vertex on the top, in which case there are two vertices at the bottom, and here I've got two vertices on top. So altogether, those are the only possibilities. So the answer is 4 plus 12, which is 16. There are no other cases. So there are 16 such triangles that you can draw. Now there is something here which I think is worth talking about. I'm just going to go to a whiteboard. You see, in the second situation where I got 6, we landed with 6. The question could have been asked like this. I've already got one vertex. I need to find two vertices, and the two vertices can be chosen from 4 vertices. So the problem here was choose 2 vertices from 4. And the answer was if you remember, the answer was 1 plus 2 plus 3. And there was 6. Now, interestingly, these vertices of a, we could have said 2 dots from 4 dots. It doesn't matter whether it's dots or whatever it is. In general, it's 2 objects from 4 objects. Could be 2 people from 4 people. Or 2 cars from 4 cars. So you want to choose 2 objects from 4 objects, and the answer is 6. Now, here's an interesting fact. The number of ways of choosing 2 objects, this is very important. You'll be using this fact many times, right, throughout the Olympiads. The number of ways of choosing 2 objects from, I'm not going to say 4, I'm going to say n objects. Oh, I said I'm not going to say 4, and I actually wrote down 4. Okay, the number of ways of choosing n objects from from 2 objects from n objects is 1 plus 2 plus 3. And you go on. Now see, we finished at 3, right? Because we had 4, you see. So you finish at 3. So here you'll finish at n minus 1, the number just below n. It's 1 plus 2 plus 3 up to n minus 1. Now for this, all of you, hopefully you know the formula, right? No Olympiad student should not know that 1 plus 2 plus 3 plus 4 up to n, there's a formula for this, and that is n into n plus 1 over 2. A very nice formula. 1 plus 2 plus 3 all the way up to n is n into n plus 1 over 2. I'm not going to go into the details of that, but if you go into my book, you will see in the section called, what is it called? Formula. Interesting formula or something like that. There's a chapter on interesting formulae. And if you go there, you will see why 1 plus 2 up to n gives you is n into n plus 1 over 2. So in this case here, to get back to our problem, you got n minus 1 it's finishing off with. So it's n minus 1 times the next one. N plus 1 is the one after that, divided by 2. N plus 1 is the number that succeeds n. The number that succeeds n minus 1 is n. In fact, it's more familiar to write down n into n minus 1 over 2. So this is a very, very important formula. The number of ways of choosing two objects from n objects is n into n minus 1 over 2. Is n into n minus 1 over 2. I'm going to write this as a full sentence here so you can see it. N into n minus 1, 2. And that is the number of ways of choosing. Okay, so this formula is important enough to enclose it in a rectangle as I am doing. Don't ever forget this. The number of ways of choosing two objects from n objects is n into n minus 1 over 2. Okay, so in the case of 4 objects, right, we had number of ways of choosing 2 dots from 4 dots is 4 times n minus 1 is 3, right, divided by 2, 12 over 2 is 6, right, as advertised. All right, so let's get back to our questions and get to the next problem, which is problem number 16. A hiker leaves home and walks south for 1.5 hours. So you walk south and west. South is this direction. South like that, and then west is that way, west, and then he breaks for 20-minute lunch and then walks directly home along a straight line, right? Now, assuming he always walks at the same speed, for how many minutes was he away from home? Now, we know that distance is equal to speed times time. So this is a problem involving time and distance. And we know an important formula that distance is equal to speed times time. Okay. So if he's walking at the same speed all the time, then is covering the same distance. If he travels in a certain period of time. So what we are going to do is, let me just get to the next. Here, I've drawn the diagram. When he starts here and he goes south, but I put 1.5 here. This is 1.5 hours. This is not a distance. This is a time, right? But if you want to know the distance, it's 1.5 times the speed that he is traveling. So it's 1.5. If he's traveling at the speed, say v for velocity, the distance he will travel is 1.5 v, and here the distance he will travel is 2v, right? It comes down south, and then it goes west. Oh, yeah, this is west, goes west. Then it goes straight back home. So now you can calculate this distance here, And when you work it out, this is a right angle triangle, right? When you work this thing out, you will have, you can work out this distance here. It is equal to the square root of, in actual fact, it will be 1.5, which is 3 over 2. So it's 3v over 2. 1.5 is 3 over 2 times v, all squared. And here, this is 2v, this distance, all squared. And that is this distance here, the hypotenuse. Now, when you simplify this, what do you get? Yeah, you got 9v squared over 4. Squaring it. And this is 4v squared. And then when you take your denominator is 4, you got 9v squared. And yeah, this is 4 times 4v squared, which is 16v squared. So you got square root of 25v squared, which is 5v, over square root of 4. Square root of a fraction is the square root of the numerator divided by the square root of the denominator. And this is your 2.5 v. That's where this 2.5 comes in. So there should be a v there. All right. But in other words, the speed, the distance is this. So he would have traveled for 2.5 hours. Yeah. So now to calculate the total time, remember, assuming that he always walks at the same speed, for how many minutes was he away from home? Right, so here he was away from home for 90 minutes, 1.5 hours, is 60 plus 30. Here he was away for 2 hours, is 120, 60 minutes. But he rested for 20 minutes, so you have to count that time there as well. And then it took another 2 hours, which is 120 plus 30, 150. So the total number of minutes he was away from home is these 4 numbers added together, and that gives you 21, 23, 380 minutes. Okay, so that's the answer to that question. Okay, so next problem is I hope you understood this. It's a distance time problem, but you notice that in my diagram I didn't put the v at all because it didn't really matter. We're only counting the time. So this is you can call this a time triangle if you like. This is a time here, time. You don't always do that. You can only do that if you got the same speed right throughout, right? Because they say here it travels at the same speed. So then you'll see the v's appear all the time. So when you're just dividing this by its speed, you'll get 2.5 hours. All right, let's not say too much more about that. The next problem is what's going on here? Okay, so the next problem is this. Problem 17. There are 367 pupils in a school hall. What is the probability, expressed as a percentage, that at least 2 of them have their birthday on the same day? Birthday is like 18th of August, not birth date. We're not including the year in which they were born. So we don't include the 2008 or whatever, right? So what is the probability that at least two of them have their birthday on the same day? Now, 367 is an interesting number because it's got something to do with 365 days in a year. So just remember, you got the number of days in a year is 365, and in a leap year is 366, and you've got more pupils than days here. All right, so that's an observation we make. But now, how do we translate that to answer this question? The question is, what is the probability that at least two of them have their birthdays on the same day? All right, I've written down something here. Here's a statement. It will always happen that there are at least two pupils who have their birthday on the same day. It'll always happen. If you've got 367 pupils, right, there will always be two people who have their birthday on the same day. Okay, now this is a kind of a logical argument. They say otherwise. Now, what do you mean by otherwise? It means, okay, I'm making the statement here. I'm saying there will always be at least two pupils who have their birthday on the same day. If this is not true, it means that you will have all the pupils having their birthdays on different days. So if otherwise, the pupils will have all their birthdays on different days. But there are at most 366 days in a year. So is it possible that you can have 367 people who are filling in 366 days? It's not possible. If you got 367 people filling 366 days, you must have at least one of those days having two of those pupils. What do you mean by that? One day, a certain day has got two pupils, one of the days. And that means that these two pupils have the same birthday because we are counting birthdays. Right? So the conclusion is always happen. So what is the probability? When something happens all the time, right, the probability is 100%. Right? So that's the answer. It's happening all the time. If it happens half the time, the probability is 50%. And so on. Okay, so the answer to this question is 100%. It happens all the time. Okay, so let's get on to the next problem. Now here, you got two circles, identical circles, are drawn inside a rectangle. You can see you've got a rectangle and you've got two identical circles. Identical means you've got the same radius, basically. But that's the only thing that determines a circle, just the radius. If the area of the shaded region is x minus pi y, so now this question is phrased in a rather frightening way. When people see this, they say, oh, I don't know how to do this. But watch, it's very easy. If the area of the shaded region is x minus pi y, then what is the value of x plus y if x and y are positive whole numbers? Okay, so you have, let's just put this into a bigger picture like this. And we know that the area of the shaded region is x minus pi y. That we know. X minus y pi. That's the area of shaded region. All right, so let's calculate the area of the shaded region. Right, we don't know what the shaded region is. So let's give a name to the shaded area. It's unknown, so we can give a name to it. Let the area of shaded region, you don't know what that is. B, we can't call it X because we've got X and Y already there. Let's call it A, capital A for area. All right. Now, if you look carefully, you will see that some parts of the top part are identical to the, like this part here is identical to this. That white part. And this part here is identical to that. And this part here is identical to that. And finally, this part here is identical to that. So what you've got actually, because of the symmetry of this picture, the shaded area occurs twice in this inside this rectangle. So I want to calculate the full area of the rectangle. I know its length is 16 and the breadth is 8. So I know the area of the rectangle. So that I'll try to get an equation involving A. Okay, I see that A is the area below the line, and the same area is repeated above the line. I've shaded it. But in addition to that, I've got these two areas here, whatever they are, but that whole area will be equal to the area of the rectangle, because if you take the bottom shaded area, the top shaded area, and the two unshaded areas, you'll get the area of the rectangle, which is 16 times 8. So the only thing now that is left to do is to find the area of these circles. But the area of a circle, we know, area of any circle, right? You should know that the area of a circle is pi r squared, where r is the radius of the circle. Now, the radius is not given here, but on closer examination, you will see that from that point there down to the bottom here, that length is actually equal to 8. It's the same as this, right? I think I mentioned this last week, that the radius is always perpendicular to the tangent. This is a tangent, and this thing here, right, this is perpendicular, draw perpendicular, so that goes through the center. So this thing here is the diameter. So you can see the diameter of the white circle is 8. So the question is, what is the radius? If the diameter is 8, then the radius will have to be 4. So we can see that the diameter is 8. So the radius is 4. So the area of the circle is 16. The area of a single circle is 16 pi, but there are two circles here. So these two circles, the combined area is 32 pi. Right? So you've got an equation. The shaded area, which is doubled, plus the two circles, which is also doubled, the area of each circle. And now you can work out what the unknown is. The unknown is A. That's the area that you're looking for. It's 16 times 8, which is 128 minus 32 pi. If you bring the 32 pi on the other side, and that gives you the area of the shaded region. It is 64 minus, I'm sorry, this is 32 pi. So when you divide by 2, 2a is equal to this. It's 64 minus 16 pi. Right, so this is the area that we're looking for, 64 minus 16 pi. So here they tell you that the area is x minus y pi. So you can see this is x minus y pi. So that immediately tells you that x is 64, y is 16, and therefore the question was, always answer the question. Then what is x plus y? So we got x and y. X plus y is 64 plus 16. And that is 80. So the answer is 80. The last part, what I said, is very important. You must see what the question is and answer the question. It's so unfortunate that many people know how to solve a problem, but they don't. They solve the problem, but they solve something that they were looking for. And they say, oh, okay, I've solved it. But you must answer the question, right? Otherwise, you get it wrong. So here the question was, what is x plus y? We got x, we got y, and x plus y is 80. Okay, so let's just get on to the next. Now here you've got some funny things. You got 1 with an exclamation mark, 2 exclamation mark, 3 exclamations. So what are these things? Right? These things in mathematics, they are used quite often. What it means, it says here, 3 exclamation mark is 3 times 2 times 1. 4 exclamation mark is 4 times 3 times 2 times 1. So in other words, 3, this thing here you read as not exclamation mark, but as factorial. Just remember, that is read as factorial. So you got 1 factorial plus 2 factorial plus 3 factorial plus 4 factorial plus 2019 factorial. And the question here is, what is the units digit of this thing? Now, what do you mean by 3 factorial? We just said it's 3 times 2 times 1. Okay. All right, so let's just calculate this now. This 1 factorial is simply 1. 2 factorial is 1. In fact, you can write this as backwards, rather than say 3 times 2 times 1. I prefer writing it as 1 times 2 times 3 and stop there. And this is 1 times 2 times 3 times 4 and stop there. That's 4 factorial. So this is 1 times 2. 2 factorial. This is 1 times 2 times 3, right, which we saw here, and that is 6. 3 factorial is 1 times 2 times 3. 4 factorial, you can see, is 4 times 3 is 12, 12 times 2 is 24, so it's 24. But what's interesting is 4 factorial is 4 multiplied by the one that we just worked out. So it's 4 times 6. See? Because this part here is 3 times 2 times 1. And if you take 5 factorial, it will be 5 times the one which we just worked out, and that is 120. 5 times 24. You can try it. You can just put a 5 here. 5 factorial is 5 times 4 times 3 times 2 times 1. But 5 times, this we already know is 24. That's why you get 120. The next one will be 6 times this, which will be 720. The next one will be 8 times this. And so on, going all the way up to 2019. I've written it vertically because I want to add all these. Right? And I'm interested in the units digit. In other words, what happens at the end here? Now you'll see the units digit, you've got 1 plus 2 plus 6. 1 plus 2 is 3, 3 plus 6 is 9, 9 plus 4 is 13. But you've got zeros right throughout here. Because each time I'm multiplying something, it's already got a 0 in it, right? So even if you go all the way up to 2019, it gives you a lot of numbers, 2019 numbers in this column. But every one of these past this point here will all have zeros at the end. So when you're adding, the units digit is just 1 plus 2 plus this 13, you carry 1, but you're really not interested in what goes on here because you needed only the units digit. So the answer is 3. We needed to know only the units digit. It's 13 carry 1. You have to put a 3 there. And so we are answered the question because this is what was asked. Okay, so this is where we are now. We get to the next problem, which is problem number 20. Problem number 21. Athletes A and B run at constant speeds. Now it's getting more and more difficult now as time goes on. Okay, as the numbers increase. Athletes A and B run at constant speeds. Again, like the previous case, they run at constant speeds in opposite directions around an athletics track. So they don't tell you what the shape of the track is, but it doesn't matter. We can assume it is circular. But they run at constant speeds. So in the same time, they will travel the same distance. But they run in opposite directions around this track. Now they begin at the same time, from the same point, but they travel at different speeds because it says here now, for every 2 laps that B completes, A completes 3 laps. So A is traveling faster than B because he completes 3 laps when B completes only 2. Okay. So now the question is, how many times do they pass each other during A's first 10 laps? Okay, so now you have to figure out B completes 2 laps. When B completes 2 laps, A completes 3 laps. Okay, let's put this in the form of a picture. And I've actually, okay, let me just make this thing a little bit larger. Okay, so here I've got, I'm assuming they're traveling around in a circle. It doesn't really matter, but it makes it easier like this. So they start. Now remember, they travel in opposite directions. So A goes off on the red part and B goes off on the blue part. So let's find out where they meet. Now, A travels, when he does 3 laps, B does only 2 laps. So in other words, the ratio of the distances, this is 3 parts and this will be 2 parts. So what does this mean? It means that the red part is 3/5 of a lap. A full lap is this, right? A lap means the part that he takes to get back to start. From start, he comes back to start again. So that's a full lap. So the red part is 3/5 of a lap, while the blue part is 2/5 of a lap. It has to be like that because A is traveling. For every 3 laps, A does, B does only 2. So to just make a conclusion from this, I'm just going to look at this. When A travels, because the question is, A completes 10 laps altogether. A completes 10 full laps altogether. Now, after traveling 3/5 of a lap, he meets B. Now, if he goes on like this, if he travels another 3/5 of a lap, B would have traveled only 2/5 of that. So he'll meet B. He'll meet B at some other point here, somewhere maybe. And so on. But now the points change all the time and it can become very complicated. But when you think about it, we can make this as your new starting point. And then it travels 3/5 of a lap. So A travels 3/5 of a lap, another 3/5, another 3/5, several 3/5 of laps, and each one of them, they meet. So you want to know how many times they meet. So they meet, but it travels 10 laps altogether. Right? So you want to know 3/5 plus 3/5 plus 3/5 gives you so many laps. So how many 3/5 are there in 10? So the question that needs to be answered is 3/5 added itself to itself several times, right, is 10. So you want to know how many times is 3/5 added to get to 10. But just remember, when it travels 10 laps, they need not meet at the 10th lap. They would have met before the 10 laps have covered. Right? We saw that they need not meet here. They will meet at different places. But they want to know how many times do they meet each other. So if you let n be the number of times, they meet, we'll have to see how many 3/5 are there in 10. So that is 10 divided by 3/5. That is how you find out how many 3/5 there are. Otherwise, you can say 3/5 times n, the number of times they meet, will be equal to 10. But you just have to be careful. They need not be equal to 10 because this thing here, it need not be, they need not meet at the starting point. I don't want to go into that. But we'll see just now that it really has to be less than or equal to 10 because the number of times they meet might not be the starting point. But if you look at this now, here you will get, multiplying, divide fractions, you invert 50 over 3, you get 16 and 2/3 when you work this thing out. Now you can see now you got 2/3 of a lap. So you got 16 and 2/3 of a lap. So the number of times they meet is only 16. They can't meet 16 and 2/3 times. They meet there, and then after that, when 8 travels another 2/3 of a lap, you'll come back to the starting point. But so essentially, we should have said that this thing here is less than or equal to 10. And then you will see that n is less than or equal to 16 and 2/3. And n is a whole number, you see. This is the number of times they meet. And the largest number below 16 and 2/3 is 16. Right? You can't meet 16 and 2/3 times. It's a number of times they meet. So it's the largest number which is smaller than 16 and 2/3. So it's a little bit tricky, but the answer is 16. Basically, you're asking how many 3/5 are there in 10? So you can see the mathematics is so easy. There's no, all you have to do is to calculate 10 divided by 3/5. You're not doing anything very fancy, see? But to think and get to that is where the issue is. And the issue is that each time they meet, you can regard that as a new starting point, right? And then it'll be another 3/5. There you can get a new starting point. another 3/5, and then you will get to your answer. All right, so let's get on to the next problem. At 6 o'clock, I will give you a chance to answer your questions. So we're at problem number 22 now. A number is chosen at random from the set containing all 3-digit and 4-digit whole numbers. Okay, you know what 3-digit numbers are, 4-digit whole numbers, which read the same backwards and forwards. So now this number here is, it reads the same backwards and forwards. This too reads the same backwards and forwards. So we choose a number at random from the set that contains all such numbers. So your set is 101 and a lot of numbers, you know, maybe 565. 4-digit numbers also. So you could have 9779 and so on. So you got a whole lot of 3-digit numbers and 4-digit numbers, but they have this property. But the question is, what is the probability expressed as a percentage of you choosing a number at random from here? And you got all the possible numbers here. What is the probability expressed as a percentage that the chosen number is a 4-digit number? All right, so you got 3-digit numbers and 4-digit numbers. So let's say we've got X 3-digit numbers and you got Y 4-digit numbers. Let's try to calculate how many 3-digit numbers are palindromes. You call these numbers which read backwards and forwards even words also. A palindrome like level is a palindrome. If you read backwards, it's the same word. Right? There are many words in the English language which are palindromes, but amongst numbers, you get the same kind of a thing. It reads the same backwards and forwards. So suppose now the X 3-digit numbers and Y 4-digit palindromic numbers. Okay, so now let's get to the next page. Got enough space. Oh, this is the one. Okay, so that's what I said now. Let X be the number of 3-digit numbers and Y the number of 4-digit numbers. So we need to calculate the probability that the number you pick is a 4-digit number. So the probability will be the number of 4-digit numbers, all over the total number of numbers. That's the probability that you will pick a 4-digit number. That's what you mean by probability. What are the chances of picking a 4-digit number, right? It's usually a fraction or a percentage. So it's the number of ways of picking a 4-digit number over altogether. And altogether, you get X plus Y because I've given X to the number of 3-digit numbers. So we need to calculate X and we need to calculate Y. So let's do that now. Okay, so X is a 3-digit palindromic number. Okay, now how do you count all these numbers? Now watch carefully. Now, let's assume that the middle number is 0. Right? If the middle number is 0, how many palindromic numbers are there with the middle number 0? 3-digit numbers. Okay, you can't start with 0. It's a 3-digit number. So you can start with 1, or you can put 2, or you can put 3, and the last one will be 9. So the number of 3-digit numbers, if I put x here, they're the same numbers, right? There are 9 such numbers where the middle number is 0. Right. Now let's count all the numbers where the middle number is 1. The same argument will tell me there are 9 such numbers there. Or the middle number is 2. Again, you'll have 9 such numbers. 1, 2, 1, 2, 2, 2, 3, 3, 3, 3, 2, 3, 4, 2, 4, and so on. Okay, so the middle number can go all the way up to 9. So the number of 3-digit palindromic numbers, and the middle number could be any one of 0, 1 up to 9. If it's 0, there are 9 such numbers. If it's 1, it's 9 such numbers, and so on. And if it's 9, there are 9 such numbers. But so how many do you have altogether? It will be, you have to add 9 to itself. How many times? There are 10, because there are 10 numbers here. 1 to 9 and 0. So that gives you 90. So there are 93-digit palindromic numbers. In other words, x is equal to 90. Okay. Now, let's look at what the 4-digit numbers are. Okay, now you got 4 digits. It reads the same backwards and forwards. So what are the numbers? Like, for instance, 6, 9, 9, 6, or 8, 7, 5, 5, 3. You can't have 7, 5, 4, 3. These two numbers have to be the same. If you read it backwards, the second number must be the same as the third number. So in this case here, what we have here is the two middle numbers are the same. See, the two middle numbers are the same for the palindromic 4-digit numbers. Okay, so so let's do the same as we did before. Suppose the two middle numbers are 0, or they could be 1, or they could be 2, or they could be 9. And exactly the same arguments will tell me that you can only have 1001, 2002, and so on. And it'll be exactly the same as the previous one. Again, this will give you 90. Right? It's the same problem. The only thing is now you got the two middle numbers are the same. There are 10 such numbers, and each one of them have got 9 possibilities. So it could be 1001, 2002, all the way up to 9009, 9 possibilities. So y is also equal to 90, strangely, although they are 4-digit numbers. The reason is the 2-digit numbers are the same. So you got x is 90 and y is 90. So the probability is altogether you've got 180 such numbers. If you list all the numbers, the 3-digit numbers and the 4-digit numbers, you'll have 180 of them. And of that, 90 of them are 4-digit numbers, right? So therefore, the probability of picking a 4-digit number from that lot is 90 over 180, and that is a half, which is 50%. Remember, the question was, you need to calculate this as a percentage, I think they said. Expressed as a percentage, okay? So we have to write it down like that. If you put a half, you get it wrong. You'll get it wrong because you're not answering the question. It must be expressed as a percentage, so it'll be 50%. All right, so that is problem number 22. Problem number 23 is the next one that we go to. All right, now it's getting a little bit, as I said, as you go further down the line, they become more and more difficult. Now you got A and B are both 2-digit numbers, like 35, 93, or whatever. They have a highest common factor of 6. you come across highest common factors. And the lowest common multiple, LCM, lowest common multiple, 180. And in primary school, you learned how to calculate the HCF and the LCM of a collection of numbers. But here we have only two numbers. And you got the HCF is given as 6, the highest common is 6, and the LCM is 180. So the numbers themselves are A and B, and you're asked to calculate the smallest possible value for A plus B. Right, so this is quite a challenging problem. Now listen carefully. I want to just analyze something here, because I'm about to tell you a very important fact. Let's take two numbers. Take two numbers like, say, 24 and 56. How do you find the LCM and the HCF of these numbers? Okay, so if you remember, you wrote this as, you factorize it, it's 2 times 2 times 2 times 2, 8 times 3. And this is 8 times 7. I'll put the 7 far away. And then to work out the HCF, you found how many of these numbers repeated. So you got 3 2s here, 3 2s here. So you had 2 times 2 times 2. This is not repeated, that is not repeated, that is not repeated. So you actually are finding it's 2 cubed. Now if you write this as 2 to the power of 4 times 3, that's another way of writing it. This will be 2 cubed times 3, 2 cubed times 7. 2 cubed times 7. Then what you are doing is you say the HCF is actually 2 cubed. So it's the smaller of these two powers which occur here. 2 to the 4th, and this is 2 cubed. So HCF is the smaller of these two powers. And here is 7 to the power of 0, if you like. And this is 3 to the 0. So if you write them all having the same denominators, 2, 3, and 7, the smaller of 0 and 7 is 0. So I should have had 7 to the 0, but I'm not putting that down because that's 1. And here too, I should have had 3 to the 0 because that's the smaller of these two powers. So I'm not putting that down. So this is the HCM. And the LCM is you take the larger of these two powers. Now you'll see you got 2 to the power of 4. You take all the 2's that occur, and the 3 and the 7. So you take the larger of these two, 4, and 3, the larger of those is 4, and the larger of 1 and 0 is 1. You must put that, and the larger of 1 and 0 is 1. So this is, if you work this thing out, you get 336. I'm sorry, this is the only 3 2's here. I don't know what's going on here. This is, I know you guys can't talk to me, otherwise you would have told me there's a problem. This is 8 times 3. So there are only 3 2's. So this is supposed to be, it's got the same number. So if you work this out, you get 168.
Yeah, okay.
Now, the interesting thing about this is that When you multiply the HCF and the LCM, right, you're going to get the product of the original numbers.
No. I don't know.
Okay? You're going to get the product of the original numbers. Now, Sipo, can you please take your mic off? So, when you try to do this, now, Sipo, please mute yourself, otherwise I'm taking you out of the class. Okay, thank you. And if you think about it, it's because one of them is smaller, one of them is larger. So when you multiply the two together, you're going to get the sum of those two, you see. And then that is the same as multiplying these things together. All right, look, I took time to do that, but it's not so important. What is important is that the product of your original numbers, it's an important fact, 24 times 56. And if you work this out, you get, I think, 1, 3. What is this? 1344. And if you multiply 8 times 168, you get the same thing. That is your LCM times HCF. You get 1344. You can try it. So it always happens that the product of the HCF and the LCM is equal to the product of the original numbers. Now, why am I saying that? That fact is important in the solution of this problem. Okay. If A and B are positive integers, then their product, AB, is equal to the product of the HCF and LCM. Now let's go back to our original problem. It says here that A and B are the highest common factor of these two numbers is 6. Right. Now let's just look at that. The HCF is 6. Of which two numbers? Of your A and B. All right, so you got A and you got B. You don't know what they are. But the factor of 6 is a factor of A because it's a common factor. And 6 is a factor of B as well. So I can write A as 6 times M and B as 6 times N. Right? Because 6 is a factor, so A can be written as 6 times M. Asha Shirk, can you please mute yourself? So A is 6 times something and B is 6 times something, right? Because it's the highest common factor. And M and N, they don't have any factors because 6 is the highest. If M and N had any common factors, that would have been absorbed into the 6. So M and N don't have any common factors apart from 1. Okay, so A is going to be, and B looks like that. And we know that the product of A and B, we just said that, is 36 MN. And that is equal to the product of that HCF and LCM. And it was given that the HCF is 6, the LCM is 8. So you have the product is 6 times 180. So you got 36 times Mn equals this. So you can calculate M times N. It is over 36. Okay, and we don't need calculators to solve this problem. 6 goes in 36. 6 times 6 goes into 180, 30 times. So the answer is 30. You don't have to multiply them and divide. just using fraction and cancelling, you can solve it. So m times n is 30. Okay. Now, but we don't know what m and n are. There could be many possibilities. So let's just look at what are the possibilities for m and n. I'll put it down like this. Two numbers whose product is 30. You could have 130, 1 times 30. I'm putting it like this. mn with a bracket, m equals 1, n equals 30. It's easier to write it like this. Or you could have m is 2, in which case it's 2 times 15, or 3 times 10, 4 times, no, it doesn't work, 5 times 6, and 6 times 5. But on this side, you'll have all the backwards now. You have 10 times 3, 15 times 2, and so on. Okay. Now the question is, let's go back to the question to see what were they asking. They said, determine the smallest possible value of a plus b. Okay, let's go back to this thing and see what is a plus b. It is 6m plus 6m. Right, that's a and that's b. And that is 6 into m plus n. So we want to have the smallest possible value of this. In other words, we want m plus n to be as small as possible. What is the smallest possible value for m plus n? I've already got m and n, right? So we'll have to look at all these and see what is m plus n. Here you got 31. Here you got 17. Here you got 13. Here you got 11. Here you got 11. And the same numbers repeat on the other side because they're just the reverses of these. So the smallest value that amongst the m plus n is 11. So the smallest value of a plus b is 6 times 11. That's the smallest value of m plus n is 11, and therefore it's 66. We can actually find the smallest of these because there are many possible values, answers for m and n, but not infinitely many, just a few, because you know that the product is 30. So the smallest value for m plus n is 11. So the smallest value for a plus b is 6 into m plus n, which is 66. Okay, so let's just get on to the next problem. Okay, we go to problem number 24. And the problem number 24 says 3 objects A, B, and C are weighed on a balancing scale. The following observations were made. So you got various equations. 4A plus 2B equals 3C. Right? These objects, their weight is A, B, and C. So when you add these weights, this is what you're getting. And the question is, find, if I put 3 of the object A and I put 1C on one side, this is a balancing scale. So in actual fact, what you've got is something like this, and you got like that, and you're putting stuff here and you're balancing it out. So you got 4 A's and 2 B's on one side is the same as 3 C's on the other side, and the same thing with the others. So I got 3 A's on one side and a C on one side, but how many B's must I put on the other side to make this balance, right? So it all, it looks as if it's very difficult because you got a context here, but this is really working out equations, all right? So let's see now exactly how one goes around doing this and why. Okay, I didn't leave any space for this. I'm not going to try to leave any space. Let's just do it on this page. Let's clear all the drawings. Okay, now the argument is as follows. I want to get 3a plus c, and I've got b's on the side. So the way to do this is to find a in terms of b and c in terms of b. And then when you add these two, you'll get something times b. So we need to work out a in terms of b and c in terms of b. And the way to do that is to bring all the a's and c's to one side. Like here, I've got 4a minus 3c equals minus 2b. You have to do it like that, because you want the a's, a in terms of b. So I must get an equation, put a's and c's on one side and b's on the other. And here too, I need to put a's and c's on one side, and I'll get 6a minus 2c (6a minus 2c) equals 2b. The reason why I put it far away is because 2 is a common factor, you see. So rather than do that, I can cancel the 2 straight away, and I get 3a minus c equals b. So now you've got 2 equations in 2 unknowns, a and c, but you've got b's on the other side. Now I can eliminate a and eliminate c in the way you, oh, okay, you are juniors. So how do you work out 2 equations like this? How can I find out what a is in terms of b? If you look at this, I can work out c in terms of a and b. Let me put the sign here, which means implies. I can put c equals 3a minus b. If you bring the c to this side, and then you take the b to the other side, you got c is equal to 3a minus b. And then you can put the c there, and you get 4a minus 3. Now replace c by 3a minus b. So the c's have gone away, you see. So that's the whole idea, to eliminate the c's. And to eliminate the c's, I put c in terms of the other ones, and they are gone because you have replaced it. It's equal to minus 2b. And now you can bring all the a's to one side. Remember, we needed to find a in terms of b. So you get 4a minus 9a is minus 5a. You bring all the a's to one side, and here you got minus 2b. Here you got plus 3b. If you take it to this side, you get minus 3b. So you get minus 5a equals minus 5b. And you get a equals b. All right, so this gives you a equals b. So there it is. I found a in terms of b. So now I'm halfway through. I need to find c in terms of b. And to do that, you go to an equation where you had c, there it is, right? And replace a by b, because we found a in terms of b. So you can put c is equal to 3b minus b, because a is equal to b, you see. So 3b minus b is 2b. So you got a is equal to b and c equals 2b. So the idea is to eliminate unknowns. And the way to eliminate unknowns is to find something in terms of the others, so that you can replace, as we did here, we can replace that quantity c, like the way we did here, with only a's and b's, and then c's go away. It's eliminated. Once it's eliminated, then you see how quickly you can get to a in terms of b. The same thing here, right? Now you got a is equal to b, so you can replace the a by b. So a is eliminated, and you got c in terms of this. Now you can calculate 3a plus c. 3a plus c is 3b plus 2b. and there's 5b, and that's the n that you're looking for, because n is equal to 5. Right. So 3a plus c is 5 times b, so immediately you know how many b's there are that will make up this. So that's the answer to that problem. It's a question of solving equations, although the equations look very difficult, but the trick is to find some unknown in terms of the others. When you do that in terms of the others, right? That is why we did this, because we found C in terms of the others, A and B. When you do that, then you can replace C by the others, and that reduces the unknowns, right? And you can solve. Okay, so we're going to go to the last one. We're going to problem 25 now. Okay. So problem 25 is, you got a diagram here, and you got some lines drawn, and you're asked to calculate x. Okay, now this is the last problem in this Olympiad paper, and you can expect it to be quite a challenging problem. And when you try to work out x here, no angles are given. Not a single angle is given, and yet you're asked to calculate this. So of course, there are angles here because you got a lot of 90 degrees here. These are all squares. So there are angles, but how do you get to this? You got all kinds of, you've got an acute angle here, and you got some other angles. How do you get to this? So this is where you use ingenuity to solve this problem. Okay. How do you get to x? When you see the solution, and if you really like mathematics, you'll marvel at it. Okay, it's so beautiful. Okay, the argument is as follows. I've got x here, right? It's sitting in a very awkward place. Maybe I can transfer the x to somewhere, right? By transfer, it means that if I got parallel lines, then this x here will be equal to something. So maybe I need to draw a parallel line somewhere to take that x and put it somewhere. You see, like this line here, maybe you can put a parallel line to this, but you can't draw a parallel line easily here with these squares. But here I can draw a parallel line to this, right? Because this point connects this point, which are two opposite points of a rectangle. I can do the same thing with this point here. And I want to draw
It's getting late.
a line parallel to this. When I join these two, this line will have to be parallel to this because it's the same picture. See, if you like, these two are the same. This and this are the same, and they are parallel. So this entire figure will be a parallelogram. But let's just ignore that. This line will be parallel to this. You can see intuitively it's clear. So therefore, you've got the x, which is here, will be equal to a corresponding angle. This x here is equal to this x here, the corresponding angles. So I've transferred that x here to that point. All right. Now, okay, it's sitting in a more comfortable place, but we still don't know what x is. And to complete this thing here, this is where the ingenuity comes in. What you have to do is draw a line down here and extend this line. Because what you can do is, you see this red line here. Now, when I extend it like this, I will see that the red line is actually equal to this thing here. Because those, you're joining opposite corners of a rectangle, a 2x1 rectangle. And here too, you're doing the same thing. You're joining opposite corners of a 2x1 rectangle. So this line here is the same as this line. So what you've got here is a black line and these two lines which you've drawn. This is an isosceles triangle because these two lines are the same. Now, okay, you've got an isosceles triangle, but now how do you find the x? Okay, so you got that angle is x, and therefore this angle here is x because these two are equal. But now the question is, what is the third angle? If I know this angle here, then I can calculate x. Now the question is, do I know it? Well, let's see. Let's put a dot here. This angle here that we are looking at is dot plus circle. I put a dot here and I put a circle here, right? Is dot plus circle. Now, if you look carefully, you will see that the dot is 9. Oh, I'm sorry. That this dot here is the same as this, that dot. Now you'll ask me, how do you know that? Why are these two dots the same? The reason for that is that this dot here is half the rectangle. See here. This dot is an angle in half the rectangle. And this dot here is also an angle in half the same rectangle because you've got the same rectangle, 2x1. Right? So these two triangles are really the same. They're congruent. So therefore, these will be equal. So now dot plus cross, you can see what that is. It's 90. If you look at it here. But once you got dot plus cross is 90, then you got 90 is this angle here. And when you add it to twice your angle that you're looking for, x plus x, you get an angle of a triangle, and you'll see that x is 45 degrees. So without any information whatsoever, and when drawing some new constructions and observing that you got almost identical pictures repeated different places, you can actually calculate the angle x to be 45 degrees. Okay, so the time now is 6:10, and I've gone 10 minutes beyond my time. A lot of people have left. So I'm going to now stop the recording and entertain questions. First, I'll look at the, let's stop the recording first.